Alright, so for the linear graph, we have, for rate, I'm going to do that as our practice, 4.69 is our maximum, so 5, 5, 4, 3, 2, 1, and 0 on that. And that's our photosynthetic rate. Remember your units. So we have number of discs per minute here. And then for our x-axis, let's use light energy or wavelength or length. Alright, so we're going to stop with, alright, so we're going to do light wavelength, and its units is in nanometers. So we'll go from the most energy at 450 and work up to the least amount of energy at 700. But you know, I'm going to put 0 on that end as well. I know it's a little weird, but there would be no energy in that particular wavelength. So 450, we need to go up to 700, 550, 650, and 750, and then we'll do no light. And then there's also a white light, which I'll go ahead and put in here, but for our hypothesis it's not really necessary. Alright, so our first point is actually dark, and it has 0 for its photosynthetic rate. So put it down here. The next is red at 700, and its rate is at 4.61. We then have orange at 0.5, which orange is at 650. Yellow at 575, and that will be yellow's at 4.69. Then we have green at 525, and that is at 0.03. Blue at 450 is at 2.03. And then white, which is all of those wavelengths in one, is at 4.32. Alright, so if I'm putting a best fit line in this case I'm not going to include the no light and the white light. They're just there. It's kind of hard for this one. If you wanted to do a dot to dot, you could, instead of a best fit line, do that. And so you just kind of connect your points. The best fit line, if you did that and drew all of your dot, your line through all of those dots, I might do something like this, but it's not a really clear kind of pattern this time.